Hello everyone, welcome to today's session, demo 1171, admission control of Kubernetes cluster with Kubewarden. In today's session, we are going to look at cloud native security, what is admission controller, how Kubewarden can be used as an admission controller, and with the small demo. So myself, Karthikeyan Rajendran, I work for SUSE as solution architect, and my teammate Vijay Micheri also works for SUSE as senior sales engineer. Cloud native security, the four C's approach. Any cloud native application must be secure enough in multiple levels. It has to go through multiple security check, multiple security passes even before clearing uh, to an end customer or end user, right? So, in order to achieve that, the developers, the DevOps team have to follow security best practices of cloud computing, right? The four C's of cloud native security basically represents four fundamental layers of an application build. First level being a cloud or infrastructure level security. Second level being cluster level security. Third level being a container level security. And finally, the code has to have code level security as well, right? So these are four C's of container security basically. So for our session today, we'll be concentrating on cluster level security, basically on pod security standard compliance. Pod security standard establishes three distinct policies to cover the whole security spectrum, namely privileged, baseline, and restricted. Privileged policies are unrestricted. For example, it can be used by storage drivers, CNIs, etc. Whereas the baseline policies are restricted as possible while preventing known escalations. For example, host path, host PIDs, etc. Right. A restricted policy, on the other hand, have strict policy adherence to hardening and best practices. It is built on baseline and adds additional constraint. For example, no root, root group, etc. So these are few examples of it, right? Why are we even discussing about pod security standard compliance right now? We all know pod security policy was part of Kubernetes right from the beginning, right? It was given as a test, and this is particularly deprecated with version 1.21 and completely removed with version 1.25. So we have multiple alternatives for pod security policies, right? We have multiple admission controllers available, right? One such admission controller is our Kubewarden. So we'll look at it in the later slides, right? So what exactly is an admission controller? So once an operator submits a request to Kubernetes API server, the request will then be authenticated and authorized. It will then be intercepted by a piece of code called admission controller. This admission controller is like a door to your Kubernetes cluster, right? It intercepts and processes a request to Kubernetes API prior to persistence of the object, but after the request is authenticated and authorized. By default, this admission controller is enabled in Kubernetes, any Kubernetes cluster, right? There are many built-in plugins to let Kubernetes administrator to control what kind of requests can be accepted, right? In particular, it also provides webhook to allow external Kubernetes plugins to mutate or validate any properties of API requests. Admission controller in action, right? You see how this admission controller works. Admission controller may be validating, mutating, or it can do both. Mutation admission webhook and validation admission webhook controller execute the mutating and validating webhooks. Mutating admission controller access the API object and may add or modify the API object content, whereas a validating admission controller validates an API object content and then make sure that they are valid. The responses are returned as binary in form of yes if the project is granted permission or no when it is not. So what is Kubewarden? Kubewarden is basically a policy engine for Kubernetes. It helps with keeping your Kubernetes cluster secure and compliant. So basically, it is a dynamic admission controller, and it validates incoming requests using policies written in WebAssembly. So Kubewarden is available with Rancher. It is integrated into Rancher management server through a extension, right? And it is 100% covers original pod security policies. All these policies are migrated, and it is already available as Kubernetes policies also, right? The policies are ready to use, and there is no code to write. Easy migration script. So in case if you have a custom pod security policy, and it is easy to migrate to Kubernetes. Kubernetes uses known programming languages like Go, Rust, Swift, C, etc. Right. So it is easy for us to read and migrate existing codes into Kubernetes policies. So we can use or reuse open policy agent gatekeeper policies with Rego, which is Kubernetes basic language, programming language. So because of which Kubewarden is basically used or integrated within Rancher management server, and it is widely used and accepted as the easiest admission controller in the market. Right. Kubewarden integrates with Kubernetes by providing a set of custom resource. This custom resource simplify the process of enforcing policies on your cluster. Right? If you look at the architecture of Kubewarden, right, Kubewarden stack is made of following components like arbitrary number of cluster admission policy resource. Right, you can see there are multiple cluster admission policy resource available, multiple policy servers available, right? Yeah, as you see in the picture and the architecture diagram, and a Kubernetes controller. So what happens is basically this controller monitors the cluster admission policy resource and interacts with Kubernetes policy server component. That's the basic thing. What a Kubernetes controller does. So you have one single controller, but you can have multiple policy servers and multiple cluster admission policies as well. So if you look at the policy cluster admission policies, right? So these are policies where the policy these are where the policies are defined in the Kubernetes cluster itself, right? Uh, the policy server is nothing but a deployment of Kubernetes policy server itself. The policy defined by administrators are loaded and evaluated by Kubernetes policy server, right? So basically, when you create a policy, that is loaded and evaluated by policy server. As I said, you can have multiple policy servers in your environment. So by default, you will have one single default policy server. So these Kubernetes policies can be written using regular programming languages or a domain-specific language. These policies are compiled into WebAssembly modules that are then distributed using traditional container registries. So that's how all these policies get distributed under Kubernetes. Admission control policies. Kubernetes supports multiple policies to replace pod security policies. As you can see, all PSPs, existing PSPs, are migrated into Kubernetes as Kubernetes policies. Right, the policy can be defined to a particular namespace, or it can be defined cluster wide. The cluster admission policy works across the cluster, and a basic admission policy works across the namespace only. Right, it works within the namespace only. So there are multiple policies, as you can see: PS capability, PSP, ingress, trusted repos, etc. Right. So all the policies are available under Arctica Hub, uh, and you can see a snippet of the Articraft Hub, where you can see all these policies are already migrated into Kubernetes policy. Right. Basically, these are existing pod security policies that's been migrated towards our Kubewarden policy. You also have an option to create your own policy, so that we will look at a demo, the following demo. In this demo, let me show you how to create and enforce admission policies with examples. Now let me show you how to create multiple policies with Kubewarden. For this, we are going to use a Rancher management server, because Rancher management server has the Kubernetes Kubewarden, which is built in as an extension, where you can see under the menu extensions, Kubewarden is already installed it and is enabled. You can see a Rancher management server manages multiple clusters, and let us explore this particular cluster called Suzacon demo. The basic information about this cluster in a dashboard is available, right? The events are also available on this particular dashboard. So let's quickly move to Kubewarden menu. Like Kubewarden is a dynamic admission controller for Kubernetes. First thing you will notice is the policy server, right? The Kubewarden uses policy server to receive requests to be validated, and it does that by executing Kubewarden's policies. Basically, you can have multiple policy servers enabled, right? Right now, I have one policy server which is default. You have an option to create admission policies and cluster admission policies. The difference between these two policies are that the admission policies are specific to particular namespace, whereas cluster admission policies are applicable across your cluster, right? Let me first go ahead and create an admission policy. We will use the user interface to create our policy rather than using a YAML file. You can create your own custom policy, right? But let me go ahead and choose a particular policy called pod privileged policy. So if you are in this particular scenario, that as an operator of a Kubernetes cluster used by multiple users, I want to have tight control over who can schedule privileged containers. So in case if you would like to avoid, or if you would like to deny this privileged containers, right, you can make use of this particular policy. So to create the policy, I'm just going ahead and use defining the namespace. So in which namespace the policy has to be applicable. So I have created a production namespace, right? And I'm just giving it as a name. It is basically using the default policy server, and it is working in a production mode, right? And rules are pre-populated, and I need not change anything here. Let me go ahead and finish creating this particular policy, right? The policy is getting created. As this policy is getting created, we'll go ahead and create a cluster admission policy as well, right? The same policy steps to be created, right? So right here, we will choose this policy, capabilities pod security policy, right? So basically this policy is a replacement for Kubernetes pod security policy that controls the usage of container capabilities. Using this policy, we can allow a particular capability, drop a particular capability, or add particular capability, right? Let's get into creating this particular policy, right? Enter a unique name, right? Pod security policy net raw, and rest everything is default. Rules are pre-populated. Under settings, under drop capability, I'm going to add this particular capability called net raw. So I am denying this particular capability in order to avoid security issues like spoof, ARP spoofing. I've just created the policy. You can see the policy is getting created here, um, and it's going to take a couple of more minutes. So let's go back to our admission policy, and now the status is active already, right? Let's go ahead and try to create a pod with privileged capability, right? So for that, I'm just getting into workload deployments, and I'm just going to import a YAML file, right? So here just going to create a pod, right, which is named as privileged pod with privileged um, true option enabled, right? So this should not be created. Sorry, I have to choose production because that is where it is not supposed to run, right? The policy is defined there. And let me try to import this. It should not work as per our policy. Yes, the policy is working fine now. Right? It is not letting you to create this particular policy with privileged is true. So right now, let me go ahead and change this true to false, right? So it is privileged is false. Now I should be able to create this pod, right? Pod is already created and is running, right? This is our first example for admission policy. Now let us look at cluster admission policy, right? The policy is already up and running. As you can see, the policy is active, right? Let's go ahead and check. So there is a container which is already created. If you see this particular image, container image, this particular image is already up and running, right? So let me go ahead, redeploy this, and then try to see if this particular pod is inheriting net raw capability, right? So so I have already redeployed this particular pod, right, which is coming up as you can see here. So what I can do is I can just go ahead to this particular pod and execute a command to see if the pod is inheriting net raw capability or not, right? So I can already see that this policy, this pod is up and running. Now let me go ahead and execute a shell within this particular container, right? So let me go ahead and first run this particular command. So I'll have to before running the command, I'll have to install few packages here, right? So I'm installing this package called libcap-procs. The package is installed. Now I'm going to run this particular command, right? Capsh. This is going to give me an output of all capabilities that is inherited by this particular container image, right? Now you can see the net raw capability is not available and it is not inherited just because we have created the particular policy, right? Now what if we don't have this policy, right? Let's go back to Kubewarden menu under cluster admission policy, right? Let's go ahead and disable or delete, even delete this particular policy, right? So I'm just deleting it. Perfect, now it is deleted. Let's go back to our workload deployments, redeploy this particular pod, right? It is getting redeployed, right? So in the meantime, we'll have to go ahead and open a shell within this particular pod and then execute the previous command, right? Now I'm going to add couple of more arguments to this previous command to make sure that this particular capability is now available and is visible. So since now it is redeployed, let me connect or let me execute a shell within this particular pod container and just just paste the command. Now I'm just installing this particular package and then I'm trying to run this particular command, right? Now you can see capability net draw is enabled by default as inherited, right? So now you can make use of, again, in case if you create the policy again, this will disable the net draw capability, right? Now this is end of second. That would be end of our session. Thank you for your time and patience and interest in attending this particular session.